Welcome in, folks. We're just happy to be here on this lovely Wednesday, and we'll wait for folks to load in. I know this is on the early side, and we're glad you're with us. So we're going to get started in just a few minutes. Okay. We'll get started in about just 1 minute here. Thanks for joining, folks. Happy to have you. It's going to be a great hour. So this session will be recorded and we will post it on our YouTube channel later today. We know that there's a lot of asynchronous consumption for virtual events. So thanks for y'all for being here live. And also feel free to share that recording with your colleagues. Just gonna wait another minute or two and then we'll get rolling. Okay, I think we're gonna get rolling here and we'll just let folks roll in and welcome in, folks. Welcome to the third day of the Techlandia Summit 21 and our keynote for the Climate and Environment sessions on strategic energy management. If we haven't had the chance to meet yet, I am Sally Bell and I'm the Vice President and Executive Director down here in the Southern Willamette Valley in Eugene. With the Technology Association of Oregon. I'm going to be your facilitator this morning for our session, along with my colleague Riley O'Brien, Vice President of Events and Experiences, who will be coordinating on the back end for support. So here's a little synopsis of our keynote this morning. The global pandemic has shaped the way tech companies mitigate environmental impacts across their infrastructure, construction, and operations. The energy use of tech applications, computing systems, and data centers is a crucial strategy in how tech companies are taking a leadership role in sustainability and our climate crisis. We are excited to discuss Facebook's approach to operating hyper-efficient data centers supported by renewable energy and extending decarbonization efforts into their global supply chain in the coming decade. So before we get right down to our keynote, just a couple of participation guidelines before we start. All participants have been muted. Please remain on mute unless a TAO staff member unmutes you and calls on you to talk. You may ask or respond to questions in the chat box publicly or privately by directing your message to me or use special events. We will monitor the chat box and respond throughout the discussion. We will ask you all to engage via the participant icon on your screen. So we'll have about 30 minutes of a presentation. I'll take about 10 to 15 minutes for some scripted prompted questions for our speaker, and then we'll have some open Q&A at the end. We encourage you to engage with us on social media during the session. We're excited to share what's happening throughout the Techlandia Summit and to get participant takeaways from our events. The last couple of days have been really successful and some really outstanding sessions. As I mentioned, this session is also being recorded and will be found on TAO's YouTube channel within 24 hours of this event. So we hope that you will join us for other sessions during the Techlandia Summit this week, including a panel we have today at 11 a.m. for climate and environment. And tomorrow's sessions are at 9 a.m. and 11 a.m. focused on infrastructure. So we couldn't do this event without our investors. So a huge thank you to them for investing in the Techlandia Summit. We appreciate their sponsorship and are excited to explore topics related to agriculture, healthcare, climate, environment, and infrastructure throughout this week. So thank you to Comcast Business, to Fortinet, Grail, and SAP. So finally, it's my pleasure to introduce our keynote speaker for this session, Facebook's Global Data Center Sustainability Manager, Jonathan Rowe. And the floor is yours, Jonathan. Thanks for making time to be here today.
Of course. Thanks, Sally. Let me just get my screen share going. Is that working? You got a visual?
Looks great.
Okay. Yeah, so thank you, Sally, and also just a big thanks to the Technology Association of Oregon for inviting me to speak this morning. I appreciate the opportunity to share Facebook's perspective on energy, climate, and sustainability in the age of COVID. At Facebook, we believe that climate change is an urgent issue facing the world today, and we're committed to doing our part to address this challenge, and I'm excited to share some of that with this group. So to start off, I want to give a quick introduction to who I am and what I do at Facebook. My name is Jonathan Rowe. I joined Facebook, it's hard to believe, but almost 5 years ago. It has flown by. And I lead our data center design, engineering, and construction sustainability program. The core of this program is ensuring that all Facebook data centers achieve, at minimum, LEED Gold certification by incorporating a comprehensive set of sustainable design elements and construction practices that save energy and water, promote wellness, eliminate waste, and source materials from manufacturers whose sustainability values, efficiency, renewable energy, water stewardship, and healthy communities align with Facebook's. If you're not familiar with LEED, capital L, capital E, capital E, capital D, it is short for Leadership in Energy and Environmental Design. It's a framework created by the United States Green Building Council that outlines industry best practices across a broad range of sustainability impact categories. Things like energy and climate, water, materials, waste, health, land development, transportation, and innovation. And over the past decade, I'm proud to say that all of Facebook data centers have earned LEED Gold certification or higher, and saving energy and cutting carbon through efficient design and supporting our business operations with 100% renewable energy are central parts of us achieving that strong track record. And it all started in Oregon. Last December marked a major milestone at Facebook. It was 10 years since we started serving traffic from our Prineville data center. The Prineville data center is a symbol of many, many firsts for Facebook. It was the first data center that we designed, built, and operated ourselves after spending several years, like many other companies at the time, leasing space in co-location data centers. It was also the first time we built our own server and the first time we created the connectivity infrastructure and software to support our scale. And then we released all of those designs through the Open Compute Project. OCP is a collaborative community of tech leaders that we helped launch to elevate efficient computing technology and share out the best solutions publicly so that we could all advance and innovate faster together. Fast forward a decade, and just a few months ago, we announced that we are continuing to expand the Prineville campus by 900,000 square feet with 2 new buildings. And we anticipate keeping construction crews very busy for years to come in Prineville, with close to 1,000 workers on site at peak. And once completed, this 11-building campus will be our largest data center in the United States at nearly 4.6 million square feet, and it will represent an investment of more than $2 billion. Outside the campus fence line, we also work really hard to be a good partner and a good neighbor in the data center communities and invest in the long-term vitality of Prineville and its residents. We are a supporter of nonprofits, schools, local businesses, and other projects in the community. And through our Community Action Grants program, we fund projects that put the power of technology to use for community benefit, connect people both online and off, and improve local STEM education too. Facebook data centers are among the most energy and water efficient data center facilities in the world. And our Prineville data center is supported by 100% renewable energy, including 2 new solar projects located just a few miles down the street from our data center campus. Now I'd like to spend a little time introducing you all to a framework that explains how we're able to achieve such high level of energy efficiency in our custom-built data centers. I'll start by saying that efficiency has been a big part of Facebook's data center DNA since we started designing our first facility in Oregon over a decade ago. Smart design decisions that add up across the full stack of technology inside them, including software, servers, systems, sensors, and data science. I'm going to go a little out of sequence here and start with servers. 10 years ago, Facebook was growing really fast, and we realized that a traditional approach to building and operating our data centers just wasn't going to work. Off-the-shelf server equipment included too much stuff that we didn't need. They weren't easy for technicians to service quickly, and they wouldn't help us achieve the levels of energy efficiency we knew were possible under a different paradigm. So we designed our own servers and released that work through the Open Compute project. They are intentionally minimalist and stripped of anything non-essential for energy efficient operations. The end products use much less material and are far easier for technicians to service than anything we could buy. And this no-frills design has an energy performance benefit too. For example, a chassis that has larger fans and servers with more surface area for heat sinks lets the air flow through them more freely, so much less energy is needed to keep them cool during operations. And Facebook OCP servers can also accept a higher voltage. They have a small backup battery nearby instead of a large uninterruptible power supply battery serving the entire building. And that means that our electrical system doesn't waste energy by having to convert from one voltage to another or between alternating current and direct current as many times as other data centers might have to. Altogether, those innovative server designs help to save a ton of resources, from the materials it takes to manufacture the machines themselves to the energy and water it takes to power them up and keep them cool while we serve traffic. Next up, systems. Data centers get hot because all of the electricity we deliver to our servers eventually turns into heat. And since our servers can operate at a higher than usual temperature, that helps us keep them cool with outdoor air most hours of the year using something called direct evaporative cooling. And in places where dust or high humidity or elevated salinity in the air aren't so good for the servers, we use an indirect evaporative cooling system, which we introduced in 2018. State Point liquid cooling produces cold water instead of cold air, and that helps us build and operate efficiently in tropical regions like Singapore, where removing heat from a data center is more challenging because of the hot and humid climate. And at this point, you might be wondering, where does all that heat go? Well, for our data centers in North America and Europe, we use some of the extra heat that our servers put out and keep adjacent office spaces and administrative spaces warm during the winter. The background is actually the office space in Prineville, Oregon. So a space like this would be utilizing some of the extra heat from the data halls for heating during the wintertime. And our new data center in Odense, Denmark goes a huge step further, and it recycles excess heat into the local district heating system. All in, we expect it to be enough to warm over 6,000 homes in our neighboring community in Denmark. Sensors are next in line, and I'll start by saying that measuring, monitoring, and managing the complex interplay between the servers, the power systems, and all the cooling equipment in real time is a critical part of how we ensure that our data centers operate at peak performance. Our facility operation engineers rely on a vast network of sensors to evaluate environmental conditions like temperature, airflow, humidity, and feed all of that data into a central computer that keeps track of those trends and helps make sense of all of that data. Our earliest data center buildings, like the ones in Prineville, use something called direct digital controllers. the same kind of computer that a commercial building like an office would use to manage all of that sensor data. But over the past few years, we've switched our approach to something called programmable logic controllers. This is the same kind of building automation system that more complex buildings like a hospital or a manufacturing environment, a factory, or laboratories would use to ensure efficient and reliable service. PLC systems provide better overall control of the environmental conditions in our data centers, and they help us continue to operate at peak energy performance. Data science. Machine learning is an application of data science that helps us optimize data center efficiency using the massive amounts of data logged from our equipment sensors. We have developed some algorithms that continually sense operational conditions, compare those conditions with what we would predict them to be based on historical context and live weather data, and then raise a red flag if we need to investigate irregularities or make some equipment improvements. So if we notice that one of our sites is using way more energy than our machine learning model would predict it would, the facility engineers can start troubleshooting the root cause before it becomes a bigger problem. And we're continuing to invest in data science solutions to keep our data centers on the leading edge of resource efficiency. And finally, software. Unfortunately, this morning, I can't share any photographs of our most efficient data centers. And it's not because they're top secret, it's because they don't really exist. Even though I saved this one for last, the story of Facebook's data center efficiency really begins with the lines of code that make our platform work. For example, in 2016, we built and open sourced a new software called MyRocks, which is a clever approach to doubling the compression of an existing data storage solutions called NODB. And MyRocks cut the amount of storage servers we needed at some of our data center sites in half. And we also developed a load balancing technology called Autoscale. Autoscale ensures that we weren't wasting any energy from servers being used at low capacity during off-peak hours. And we've been improving and scaling up both of these efficiency initiatives along with many, many others. Those are just a couple of examples to minimize the amount of computing resources we need to power our platform. So the most efficient, sustainable data centers in our portfolios are the ones that we never even have to build in the first place, thanks to smart engineers developing innovative, efficient software solutions that reduce demand for computing resources in the first place. In terms of COVID impacts, this efficiency work became incredibly important during the pandemic. Pre-COVID, the most difficult stress test on our infrastructure was New Year's Eve, a single day global celebration with a huge spike in messaging, photo uploads, social sharing, that's just unlike anything else we see the rest of the year. But in March 2020, we saw the beginnings of a traffic spike that would dwarf New Year's Eve several times over, and it lasted for months. Usage of our products in many countries around the world increased by up to 40% week over week as people adjusted to lockdowns and shifting to more life online. And engineers on our infrastructure teams saw demand on our servers rise in ways they had never seen or experienced before, the equivalent of months worth of steady global growth and demand happening within days. This increased our need to build more data centers. And to help curb that need to build more data centers, Facebook's engineering team came together to drive an unprecedented efficiency initiative with improvements that make our infrastructure more resilient while also building new products to help people stay and continue to stay connected. If you'd like to learn more about that work, I recommend checking out the link on the slide right here to a blog post from last November that describes how we kept the lights on during COVID. And that wraps up the 5S efficiency framework. Even with all these efficiency measures, I have to say Facebook data centers still need a lot of resources to serve our global community. And that's why we're working to support our operations with 100% renewable energy. Back in April, we announced that in 2020, we succeeded on our goal to support our global operations. So that includes both data centers and offices alike with 100% renewable energy. And we've reached net zero emissions as a business. Moving forward, we're going to continue contracting new solar and wind projects to remain at 100% renewable energy, even as we continue to grow and build more data centers to meet the demand. Our commitment to renewable energy has resulted in 63 new wind and solar power plants, representing an estimated $8 billion of investment. And these projects support tens of thousands of jobs during construction when solar panels and wind turbines are installed on site, as well as along the global supply chain to produce those solar panels and wind turbines and towers. Today, we're one of the largest corporate buyers of renewable energy with contracts in place for more than 6 gigawatts of wind and solar energy across 18 states and 5 countries. And in 2020 alone, we contracted for approximately 1 gigawatt of new renewable energy and brought 2 gigawatts of renewable energy projects online to support our operations. All 63 of our projects are located on the same grids as our data centers, and these projects are all new resources coming onto the grid as a result of our commitment. So in terms of COVID impacts, 2020 was a big year for us. We really wanted to hit our goal of achieving 100% renewable energy. And we had a huge fleet of corporate construction, around 2,500 megawatts in construction in 2020. For both our data centers and renewable energy projects, safety during the pandemic was paramount, and construction sites had to follow local laws for keeping workers safe. So we saw situations where there were short-term outages because work stopped to protect workers in response to the guidance for protecting people. And there were also some supply chain impacts for our renewable energy projects, which meant we really had to dial up the level of monitoring and tracking delays because 2020 was such a big year and there was such increased risk that we wouldn't hit our target. But luckily, we had built in some headroom and some resilience into our renewable energy procurement deals. And we're proud of that upfront planning that helped us hit our goal. Also, most Facebook offices were closed all of last year, and most employees were working from home. So we took the additional step, since the offices were closed, of looking at where our employees were working from and covering that energy footprint of employees working from home with our renewable energy deals too. Last September, we set a new goal for the next decade of sustainability at Facebook that focuses on decarbonizing our value chain. This means that we'll be tackling the carbon emissions that come from our supply chain. These are things like construction materials, the manufacturing of server and consumer hardware, and other things like business travel and employee commuting too. Over the next decade, Facebook will work to reduce carbon emissions through efficient designs, supplier engagement, and carbon removal technology. As part of this effort in the data center construction space, over the past year, we've explored strategies to reduce the environmental impacts linked to construction activities and building materials like concrete and steel. In Altoona, Iowa, we began piloting the use of electric and hybrid electric construction equipment that uses much less fossil fuel compared to traditional equipment. And we also piloted the Embodied Carbon Construction Calculator, or EC3 for short, a new online tool created to help design and construction teams procure materials that reduce a building's overall carbon footprint. To lower the carbon impact of concrete, one of the largest sources of global greenhouse gas emissions, we partnered with researchers from the University of Illinois, Urbana-Champaign's Civil Engineering Department, to use artificial intelligence algorithms they created to develop low carbon concrete mix designs that use high amounts of byproducts from other industries as a replacement for cement. The image on the screen right now is from our new DeKalb, Illinois site, where we use this low carbon concrete mix for the slab of a pre-engineered office building that will house our construction teams as we build out that campus. And as we learn from that, we hope to scale this pilot to other facilities where possible in the coming years. So that wraps up my presentation for today, and thanks everyone for your kind attention. If you'd like to learn more, I recommend checking out our website. The link's right there on the slide, sustainability.fb.com. We literally just refreshed it yesterday morning, and it also includes our 2020 sustainability report, which includes highlights from the last year of sustainability at Facebook. So thanks again. And with that, Sally, I will hand it back over to you for some questions.
Thanks so much, Jonathan. Really appreciate the presentation. And we're going to run through a few questions and then we'll have some time for open audience Q&A. Okay, so first question. Can you give us some insight from the experience at Facebook for the data center load during the pandemic? You gave us a little bit of a high overview of the initial load, but what were the biggest challenges and insights from that time, and how will that inform your strategy going forward?
Yeah, so thanks, Sally. When the when the world went into lockdown during the pandemic, it made it more clear than ever how important it is for our services to keep people connected with friends and loved ones in times of isolation. In my presentation, I covered how we focused on that efficiency and reliability piece during the pandemic to keep our platform up and reduce the demand on our infrastructure. Again, if you'd like to learn more about that, check out the blog post on our TechAt blog called How Facebook Kept the Lights On When the World Went Remote. In addition to keeping the lights on, we also built and will be continuing to build products and services that help people stay connected. As a company, we also learned a lot about how to work remotely. And about a year ago, I think it was last June, Mark Zuckerberg announced that we want to be leaders as a company in remote working, with up to 50% of Facebook employees working remotely by the end of this decade. In the construction space, we had to be super thoughtful in how we continue to build out our global portfolio of data centers while continuing to protect our people. And for some of the major electrical and mechanical equipment that goes into our data centers, we do something called factory witness tests, where before COVID, several Facebook employees on our quality assurance team would go out and travel to manufacturing sites to verify the equipment performs as it's designed to before we install it at our data centers. But during COVID, as a company, we really minimized travel and found creative ways to do those factory witness tests remotely. It taught us a lot that we can do this kind of thing well virtually. And even as the world starts returning to some sense of normalcy and as travel begins opening back up, we're planning to continue doing a lot of this work virtually now that we've realized we can do it well. And this helps us with our 2030 net zero value chain goal, because business travel is considered part of our scope 3 greenhouse gas footprint. So those are some of the top insights and how it has informed and will continue to inform our strategy moving forward.
Thanks so much. Okay, on to a next question. How can tech companies be thinking more strategically about their role in decarbonization? What advice might you have?
Well, for Facebook, a couple things come to mind. Now that we as a business have reached net zero emissions in our direct operations, or scope 1 and scope 2 emissions, if you want to be a climate nerd, our attention has shifted to decarbonizing our global supply chain in the coming decade, meaning that we have to look really, really closely at all the stuff we buy and all the organizations that we work with, and prioritize opportunities to decarbonize their business operations in support of our value chain commitment. At Facebook, we have something called the Responsible Supply Chain Program, and that team helps suppliers like hardware manufacturers, major mechanical and electrical equipment suppliers understand their environmental challenges and reduce their impact by doing things like collecting environmental data, things like greenhouse gas emissions and energy footprint, to see where and how Facebook can and should engage more deeply. So we've now been partnering with suppliers to identify ways to help them reduce their greenhouse gas emissions. And we do it through capability building programs, things like helping them with greenhouse gas accounting and reporting, or looking for opportunity for energy efficiency improvements at their facilities. And beyond our direct operations, we're also seeing opportunities to use our own platform as a means of connecting people with credible climate science. So I talked about how last September we announced our new 2030 commitment for our value chain. We also, alongside that announcement, we partnered with the Intergovernmental Panel on Climate Change, the IPCC, and its global network of science contributors to launch a new product called the Climate Science Information Center. And it's a dedicated hub to provide authoritative information from the world's leading climate science sources. And it's really meant to increase access to science-based and dynamic climate information in support of driving awareness and inspiring more people to take action. So supply chain and using products for good are the couple areas where we're spending a lot of time thinking about our role in decarbonization beyond just our direct operational greenhouse gas footprint.
Great. So speaking of supply chain, can you tell us about some of the biggest challenges, supply chain challenges, you see in the near future based on some of those current trends?
Yeah, sure, Sally. I'll start by saying that climate change no longer feels like something in the distant future, but rather something that is very much here today. So now more than ever, it feels really important for businesses to be prepared for the supply chain challenges that are likely to come with events like sea level rise, water stress, forest fires. In 2019, we launched a program to ensure our suppliers would be prepared for the climate risks that they might face, and shared with them key learnings with them from our own operations. So we conducted this physical climate risk assessment of all our global manufacturing supply chain footprint and looked really closely at risks like sea level rise, heat stress, typhoons and hurricanes, water stress. And then we partnered with them, the ones facing some of the highest risks, to ensure that they had climate resilience integrated into their emergency planning and their business continuity practices. So supply chain resilience is now, and I believe will continue to be, very important in the future.
Thanks for that. And so here's our last question from me at the moment until we get to our open Q&A. And this is about collaboration. Can you tell us about some of the key partners that you collaborate with to achieve your climate goals?
Yeah, sure. I already mentioned a couple of them in our presentation, but I'll repeat. We're still very active in the Open Compute project that we helped found many years ago. And we use that as a forum to share with and to learn from others how to create the most efficient servers and IT equipment possible. On the renewable energy side, we are very active in a organization called the Renewable Energy Buyers Alliance. And this is an organization created to help grow demand for renewable energy and at the same time help utilities to develop innovative solutions that meet that demand for renewable energy and really work towards grid decarbonization. On the supply chain side, that same organization, the Renewable Energy Buyers Alliance, they just last year kicked off a complementary effort called Decarbonizing Industrial Supply Chains Energy, which is a bit of a mouthful, so they're calling it DISC-E for short. And one of the focus areas they're looking at tackling is building materials, things like concrete, steel, aluminum, creating a strong demand signal for suppliers to decarbonize and reduce their greenhouse gas footprint. And then finally, I mentioned it up front, the US Green Building Council. I and a couple other project managers on my team, we all volunteer time on technical committees to ensure that the LEED rating system continues to represent really strong leadership in green building principles, specifically with a focus on decarbonization, and also making sure that it's really well tailored and makes sense for the data center building asset class, which was not what LEED was originally designed for, but it's come a long way in the past several years. Collaboration's big at Facebook. There are many other organizations, but that's sort of the top ones that come to mind that I wanted to talk about.
Thank you so much.
Yeah.
I know we have some great folks here, and we're going to open it up to our attendees to ask questions. So feel free to use the participant icon to raise your hand. And you're also welcome to unmute and turn on your video, introduce yourself, tell us where you're calling in from today, who you work for. I have some other questions I can ask, but what a great opportunity to ask questions here. You can also type it in the chat. So who has a question?
Well, I have a question.
Go ahead, Ann.
Yeah, how was it working in Eastern Oregon on these sustainable efforts? Can you talk about that? Bringing that in.
Yeah, so Facebook now have, I think, 17 active data center sites in North America, all over the world, or all over the US. I try not to pick favorites, but Prineville always has had a kind of a special place in my heart. You know, I started at Facebook almost 5 years ago, and within my first couple of months, like everyone hired new into the infrastructure organization, I spent a good chunk of a week at the data center site, sort of learning about how we design, build, operate efficient data centers. It's been a while since I visited. I didn't get a trip in before the pandemic hit, but like many of our sites, again, worker safety was very important. So we had to kind of minimize the people on site for construction to the essential employees to kind of keep things moving at the level that we were allowed to within the guidance from the state. But it's a very strong construction team. It's a very unique site. If you recall one of the first slides that I presented, like showing the layout of the site, over the past 10 years building data centers there, it really is like almost like a history lesson in how we have evolved our data center design typology over the years. Some of the ones in the far distance, some of the earlier buildings, sort of like single bar data centers that are now getting on over 10 years old. And then some of the ones in the forefront were like a 2-story data center, which is one of our newer design typologies. So the Prineville Data Center is a great team, and it's also a really great history lesson in how we have evolved our approach to designing and building data centers over the past decade. Don't tell anyone else, I just said they were my favorite, because other sites get mad at me.
We're okay with us being your favorite. Now we're going to go to Allison Dowd. Go ahead, Allison.
Hi, I'll turn on my video for this. Thanks so much for the presentation, Jonathan. I felt like I learned a lot about Facebook's sustainability efforts. So I work for the Environmental Defense Fund. I'm based in New York, but originally from Oregon. And I had actually kind of 2 questions. So my first question is, one you may or may not be able to answer, but I'm curious if Facebook purchases carbon credits or offsets. And if you guys do, can you speak to some of the projects or some of the investments Facebook has made recently? I know sometimes it can be a contentious issue to purchase offsets, but I'm just curious if Facebook does so. And then my next question is, you talked a little bit about some of the organizations and companies you collaborate with, but I'm curious if Facebook collaborates with any other tech companies like Google or Microsoft or other kind of big tech companies to kind of align your sustainability strategies and find ways to, combine your efforts so that you can increase your impact. Thank you.
Yeah, thanks, Allison. Great questions. So I'll start by saying on the offsets piece, we do, but it's backing out to sort of the renewable energy piece. Our strategy on the renewable side of things is like, as much as possible, we try to purchase renewable energy that comes with bundled RECs where we can. We have purchased some offsets for portions of like some of our sites for backup power diesel emissions. We purchased some offsets related to that, but with the beginnings of our new 2030 net zero program, we're investing quite a bit this year and the coming years in carbon removal technology, which at this state is really focused on nature-based solutions. So planting forests and ensuring that those forests are around for a good long time. We expect down the road for there to be some more creative and innovative carbon removal technologies for us to invest in, but that's kind of the current state of things in year 1 of our net zero program. And yeah, we do collaborate with other tech organizations on different things. When I was joining Facebook 5 years ago, I did quite a bit of collaboration directly with Microsoft, who are also fully bought in with LEED. They were standing up their LEED volume program. So just sort of sharing notes, sharing ideas for areas and opportunities that we thought that LEED can continue to improve. Like one of those areas that was obvious 5 years ago was that LEED hadn't really evolved to account for offsite renewable energy. For a data center, they're so energy dense that it's just kind of impossible to have enough solar or wind on site to serve the building. And so most of our deals source grid scale renewables, either wind or solar, sometimes kind of far away, but always within the same electricity grid where the data center is. So, Microsoft shared a similar perspective. And that was an area where we worked to help the US Green Building Council understand that LEED need to kind of get with the times with how energy markets had evolved. And there are many other areas around water stewardship, hardware circularity, where we know that it's stronger when we join forces with other tech peers who are facing very, very similar challenges, have different ideas for how to get there, and we can get there faster with collaborative elements.
Awesome, thanks so much.
Yeah, for sure. Thanks for the question, Allison.
Great, and it looks like Steve Jennings has his hand up. Go ahead, Steve.
Hi, Jonathan. Thanks for the great presentation. I'm with Zinc 5. We're based in Portland, Oregon, and we make energy storage systems for data centers, both centralized as well as OCP. And we've been working a lot on sustainability in energy storage. And one of the question I have is, have you considered applying scope 3 level accounting to batteries or energy storage in your data centers?
We're studying it. We haven't deployed anything to date yet, Steve. But maybe as a follow-up, you and I could have a chat. I'd be interested to hear a little bit more about what you're working on to see if there's some applications that we should take into greater consideration for our data centers, if you're up for a quick chat.
Sure, that'd be fine. We recently published some information from a independent third party on battery storage, climate impact, and sustainability. And so that might be of interest to you, and be happy to share it with you.
That'd be great. Thank you.
Good. Thank you very much.
Yeah, thanks, Steve.
Do we have any other audience questions? Feel free to pop it in the chat or raise your hand. I'm happy to ask some questions in the meantime as you're all thinking. I'm curious, Jonathan, as Facebook puts out new aspirations for climate goals and things, are there any exemplars either inside or outside of tech that you feel like you're following, or that are really inspiring or informing your future strategies?
Yeah, great question. Thanks, Sally. I mean, for me personally, I think many of our tech peers have really inspiring work. Last year there was this steady drumbeat of Microsoft and then Amazon, Apple, Google making announcements about their next decade of sustainability. Each one unique, but that common thread of looking at value chain and supply chain. And I think they're just excellence across the board with parts and pieces of each of those programs. So I think, working in tech, seeing what many of our other tech peers and partners are doing is super inspiring.
Thanks for that. And then another question just on just pieces of technology. Are there any new tech products that you're really excited about, that you feel like are leading edge, that this group would really benefit from learning about, that are connected to energy management or decarbonization?
Yeah, so talk about energy management in a moment, but I'll start by saying that on the scope 3 side of things, particularly around construction, I had the slide about the low carbon concrete that we poured in Illinois. There's a startup based out of Los Altos, California called Blue Planet, which basically has a process by which they pull carbon dioxide from emitters like factories. And then they have a chemical process where they create limestone aggregate from it that can be used in concrete. So you could effectively not just have low carbon concrete, but you could feasibly, they've still got some work to do in terms of scaling it up, but carbon negative concrete, that's something that's on my radar from sort of a scope 3 materials side of thing. We're studying a lot of different energy efficiency technologies, but we're kind of quiet about the things that we're looking at until we start to implement them. So maybe you can invite me back for another presentation sometime when I have a little bit more to talk about with you. Sorry to be a little bit quiet on that, but we try to make news only when we're sort of deploying something new and exciting. So I'd prefer to maybe wait a little while before sharing some of that out in a future session.
Absolutely. Any other questions from folks? I don't want to take all the airtime. Okay, I have one more for you, Jonathan, and this is I'm trying to keep within scope, but also relative to some of the points you made in your introduction about remote work.
Yeah.
So you were giving some stats on kind of what the predictions are in remote work going forward.
Yeah.
Can you talk more about Facebook's strategy with that and also how it relates to your sustainability strategy?
Yeah, so it's still pretty early days. Remote work last year was a necessity as a result of the pandemic. But as things begin opening back up, the strategy is for roles where it makes sense and allow for it, to give people flexibility to work from wherever they want, wherever they can work, and be in the office certain parts of the year to be around their teams. There's also been some recent guidance that allows a greater amount of flexibility, whereas we might have been more of a company where there was an expectation you'd be at your desk maybe 4 or 5 days a week. There's quite a bit more flexibility in terms of giving people maybe around 50% flexibility to be in the office. We're very much sort of focused on the importance of that face-to-face connection for team building and team cohesion, but the past year has taught us a lot about the possibilities of virtual collaboration. One of the things I'm really excited about too, and Mark's been pretty public about this on some of his, if you look back at his Facebook feed over the past month, like the possibility of things like virtual reality, making it feel like even if we're great distances apart, that you can actually feel a sense of presence with the people that you are, distant from, but in a virtual environment. Maybe you're all sitting around a conference table or working together on a virtual whiteboard. That's kind of probably out of frame, but and I have my Zoom background up, so you couldn't see it even if it was in frame, but I've got my Oculus virtual reality device in the background. It's fun to kind of play around with. Haven't used it so much for like office collaboration stuff, but the games are fantastic. I gotta say, if you're a gamer, check it out.
Thanks for that. Okay, do we have any final questions for Jonathan? Or please feel free, Jonathan, to add anything else that wasn't in your presentation, or things that you feel like, if you want to leave us any final comments or resources or ideas, the floor is yours for that to wrap up.
Thanks, Sally. Well, thanks again for inviting me to present today, and thanks for the good questions, folks. Maybe as a follow-up, Sally, I could offer quite a bit of the content that I pulled together for today's presentation exists in some form or another in a variety of different blog posts or videos that have sort of come out in the past year or so. So, for anybody that wants to learn more, it was kind of a pretty high-level overview, but there's a lot more details to get into if you'd like. I could follow up with a list of links to some content if you want to dive into the rabbit hole and learn more. But otherwise, thanks again for the opportunity. I hope you learned something, and feel free to reach out if you have additional questions after today.
Thanks, Jonathan. It was a fantastic look under the hood. We really appreciate you sharing, and we'd love to share some of those resources out with our membership. Thanks all for making time to be here this morning. And we will post this recording within the next 24 hours. We also have a panel session at 11 a.m. We welcome you to come back for that. And we're going to be focused on utilities and the grid and funding models and strategies for more local Portland-based energy management. So come on back at 11 a.m. and we're going to wrap for today. So thanks again. Take good care. Stay cool out there, folks.